Alright, lesson 7. What we'll be doing is a word problem using a sine function. So the scenario is this. There's a very famous ski resort, and this function displays how much the population would differentiate over 1 year. So it's t standing for time and p standing for population. So first question is graph the function. Let's first lay out that what we have. So our amplitude, as you can see from our equation, is 2,000. Our k value 30. Our vertical shift 4,000, and our phase shift to the right 5. All that's left is to find the period. How long is one cycle? And hopefully you're already familiar with this. We take 360 and we divide it by k, and k is 30. P will equal 12. You can do it on your calculator to make sure. And this makes sense. Why? Because there's 12 months in a year. So that's why. So that's how you can verify that. Okay, our period is correct. All that's left is to graph this. What I usually like to do is use mapping notation. So our key points are first 0, 0, 0, 190, 0 and 180, negative 1, 270, etc. Because you want to graph the way the function is telling us, we would change it in a number of ways. So for the x coordinates, the way we would change it was multiply by 2,000, the amplitude, and add 4,000, which is the vertical shift, and then we do the same thing for the y coordinates. Multiply by 1 over 30 because of the reciprocal, and we add 5 because of the phase shift. And if you do that for each coordinate, hopefully you should get these coordinates. And all that's left is just to plot these. And so I'm gonna move this to the side here so you guys can see. So 4,000 and 5. So this is 5. We'll move to 4,000. Then it'll be 8 and 6,000. 11 and 4,000, 14 and 2,000, and then 17 and 4,000. Now if you connect the dots, you will see that it's similar to a sine function, and the period is about 12 months. So you can verify that you are good to go. Now that we have the graph and the function, we will be able to tell anything. We will be able to answer any question that would have to do with this scenario. For example, find the maximum and minimum. Well, the maximum was 6,000, and minimum is 2,000, and where I got that from was from the graph itself. You can see that the highest point is 6,000, lowest point is 2,000, and you can even do this without the graph. You can probably just use the equation itself by taking the amplitude and adding 4,000, and then taking negative 2,000 and adding the original min and adding 4,000, which was our vertical shift. And so negative 2,000 plus 4,000 was 2,000, and 2,000 plus 4,000 is 6,000. When did the maximum and minimum occur? Well, the max occurs at August and the min occurs at February. How did I find that out? Well, think of each number as the month. So January, February, March, April, May, June, July, August. The 8th month, August, that was the highest point, 6,000. And if you keep going, August, September, October, November, December, January, February, the next February to come had the lowest amount. And so more people come in August, that's the most, and the minimum is February. And last but not least, what is the population November? The easiest way to do this again is just to look at the graph. So we look at November, and we see it's at 4,000. But you can also use the equation. You would substitute t with 11, because that's where November is. You substitute t for 11, and if you punch this all into your calculator, hopefully you get 4,000. And same with vice versa. If they gave you the population, let's say if you put, instead of P11, you put 4,000, and you did this all over, you would probably get the first 4,000 that would come up. Alright then, so then that's lesson 7. All there is to remember is to understand what the question is asking, and from there on, it should be nothing too fancy. Thank you for listening, and